P3 integer exponents. For exponential notation, if a is a real number and n is a positive number, then the nth power of a is a to the n, which means we multiply a n times. For example, if we had a to the third power, that would mean we multiply a 3 times. There are 3 factors here. The number a is called the base, it's on the bottom, and n is called the exponent, or sometimes the power. So we're going to evaluate these real quick. Very simply, it just means we are multiplying them out that many times. So if we have 1/2 to the 5th, that means 1/2 times 1/2 times 1/2, that's 3, 4, 5, and that gives us 1/32. If we have b, -3 to the 4th power, see where the negative's on the inside, that means we are multiplying -3 times -3 times -3 times -3, and that is going to give us positive, because there are 4 negative symbols, 81. C is a little bit different. If you notice, the negative is on the outside, so really what that means is -3 times 3 times 3 times 3, which gives us -81. There is a big difference between where those parentheses are sitting. We have some laws for exponents. We would have learned this in Algebra 1. I think it was maybe chapter 7. So when we have two powers being multiplied together, so we have a to the m times a to the n, that's really like addition of the exponents. Division is then like subtraction. If we have a power being raised to another power, then we multiply the exponents. We can consider, it's not really distributing, but sort of, in number 4 and 5, where when we are multiplying, if you think about that, ab to the nth power, if that was something like ab to the 3rd power, really that means ab times ab times ab, so a gets multiplied 3 times and b gets multiplied 3 times, which is where that distribution sort of looks like it's there, but that's not really what it's called. When we have a negative exponent, don't forget that means we are really flipping our fraction over, or moving it to the other side of the fraction bar. And then when we have 0 as our exponent, anything to the 0 power is 1. And again, just to reiterate, when we see that negative, that means we need to use the reciprocal. We're flipping it over. All right, in example 2, we're just going to simplify each of these expressions. So in A, we have 4/7 to the 0 power. Remember, anything to the 0 power is going to be 1. In B, we have x to the -1st. That means we're going to flip that over, so that's 1/x to the 1st power, or just the x. We have -2 to the -3rd. So what I like to do first is deal with the negative exponent. So first, that means we need the reciprocal. So that's -2 to the positive 3rd power now as the denominator. And then when I multiply -2 times -2 times -2, that's going to give me a -8. So I get 1/8, or -1/8. In D, x to the 4th times x to the 7th, we add, so that is x to the 11th. Few ways we can go about doing E. We could still use the same rule and say that we add. So we could say that is y to the -3rd, but negative means we have to use the reciprocal. Or we could have done the reciprocal first and said that's y to the 4th over y to the 7th, and then canceled out, saying there's 4 on top but 7 on the bottom, so that would be 1/y to the 3rd. Either way, it's the same answer, so it doesn't matter. It's kind of whichever you feel like you'd prefer to use. In F, since it's division, we'll subtract. Really, you'd likely would have seen it more like this. It's just hard to do in PowerPoint. So that would be c to the 4th power. 9 minus 5 is 4. In B, we are multiplying, or sorry, in G, we are multiplying. So b to the 4th to the 5th, 4 times 5 gives us 20, so that's our new exponent. In H, that becomes 3 to the 3rd times x to the 3rd, or that would be 27x to the 3rd. And again, this isn't as clear that it is a nice fraction, but it looks like this. So that would be x to the 5th over 2 to the 5th, and let's see, 2 to the 5th is 2, 4, 8, 16, 32. So x to the 5th over 32. Okay. In number 3, again, we're going to simplify. These are just a little bit more complicated. So in the first one, we're going to deal with this 3 on the outside first. So we have 2a cubed b squared. That becomes, oops, I didn't mean equals. That becomes 3 to the third, a to the third, b to the fourth to the third. Okay. So really I have that 2 times a to the third times b squared. 3 to the third is 27, a to the third, and that became b to the 12th. And then we are just doing all multiplication here. So 2 times 27 is 54. A to the third times a to the third, I add those exponents. So I get a to the 6th, and the b is the same thing I'm going to add and get 14. All right, in part B, let's deal with those outside exponents first. So that becomes x cubed over y cubed times, that becomes y squared to the 4th. You don't have to write out as many steps if you're comfortable with this. X to the 4th, and then z to the 4th. Okay, so that gives us, we still have the x cubed and the y cubed. That now is y to the 8th, x to the 4th over z to the 4th. And then we can really just multiply everything together. So the x's will become, we add, so that's 7, x to the 7. The y's on top and bottom can do some canceling. So, whoops, I'm left with y to the, there we go. I'm left with y to the 5th in the numerator, and then the z is by itself to the 4th. All right, in C, we can do a few things here. That 6 and the 2, I can almost treat that as just regular division. So that would leave me with just a 3 in the numerator. Okay, so let's do that. We've got the 3 over. We have s to the first and s to the negative 2. So that negative 2 is really going to be brought up. So that's an s to the first and now an s to the second. This t to the negative 4th has to go down, and we already had a t squared there. All right, so that's 3 times s to the 3rd over t to the 6th. And then lastly, with this negative, I like to flip everything first. That's just my opinion, but it's up to you. So I'm going to flip that fraction. That's 3z to the 3rd over y, and now everything's getting squared. So we only dealt with the negative portion of that exponent. So that gives me 3 squared times z to the 3rd squared over y squared. 3 squared is 9. Multiply that z to the 6th over y squared. Scientific notation. So a positive number x is said to be written in scientific notation if it is expressed as follows. So x is equal to a times 10 to the n, where a has to be between 1 and 10. It can be equal to 1, but it cannot be equal to 10. And n is an integer. All right, so for example, 4 times 10 to the 13th really means that we are multiplying by a lot of tens, right? So that means we are moving our decimal point that would have been just after the 4, right? This is really like 4 point, and we are moving it 13 spaces to the right because this is a positive exponent. When it is a negative exponent, we will be moving that to the left. So if we want to write in scientific notation in example 4, first we need to turn this into a number that is between 1 and 10. So that would make it 5.692. Okay, times 10 to the. So what we have to do to this 5.692 to make it turn back into the original number would be to move these decimals to the right. We would need to move them 1, 2, 3, 4, one more space to add in a 0. So that would be times 10 to the 4th. Similarly, in this one, we need to make that 9.3, so that'll be between 1 and 10. And we're going to multiply by 10, but this time we would have to move the decimal to the left to make it look like the original number. So it'll be a negative exponent. We would have to move it 1 to go past the 9, and then 4 more to get the zeros. So that's 5 spaces to the left we'd have to make it move. All right, rating each in scientific notation, same concept. We're just going to move the decimal now 9 to the right because it's positive. So 1, 2, 3, and then we still need to move 6 more, so there'll be 6 zeros on the end of that. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my new decimal point. All right, and with B, same concept, but this is to the left. So we'll go 1 past and then 5 more. 1, 2, 3, 4, 5. So we'll have 0, 0, 0, 0, 0, 4, 6, 2, 7, 1. And that decimal point's right there. All right, in example 7, we want to let A equal 0.00046. B is going to equal 1.697 times 10 to the 22nd. C is 2.91 times 10 to the negative 18th. And we can use a calculator to approximate this, okay? So the first thing we're going to do is make everything into scientific notation. Let's move A around. So that's not perfect yet. We want that to be between 1 and 10, so we'll make it 4.6. And that would mean we'd have to move to the left. That would be 1, 2, 3, 4 spaces to the left. So times 10 to the negative 4. Okay. So really, let's rewrite this. We've got 4.6 times 10 to the negative 4 times, we've got 1.697 times 10 to the 22nd, all over 2.91 times 10 to the negative 18th. Okay. So really what I want to do is separate the numerator a little bit. That's really 4 numbers being multiplied in the numerator, right? We've got 4.6, we've got 10 to the negative 4th, we've got 1.697, and we have 10 to the 22nd. So we're going to rearrange the order we multiply them in. So the first thing I'm going to do is say, okay, let's do just 4.6 times 1.697 first. Some messy number. And then we're going to multiply 10 to the negative 4th times 10 to the 22nd. And we can kind of do the same thing with the denominator. We'll separate that out. So we will multiply 2.91 over here, and then we'll do 10 to the negative 18th. Okay. So in reality, I can separate these into 2 fractions. I am allowed to do this. As long as the numbers in the denominator stay in the denominator, I am allowed to move this around. All right, so the next thing I want to do is multiply these numbers together. So I want to multiply 4.6 times 1.697 divided by 291. So that will give me about 2.683. Now, I want to always double check that this is between 1 and 10. This time it is. If not, I may have to adjust and change the exponent on the 10. All right, here I can use my exponent rules. I would move the 10 to the negative 18 to the top, the 10 to the negative 4 to the bottom. So really I've got 10 to the 22nd on top, 10 to the positive now, 18th on top, and 10 to the 4th on the bottom. All right, so on top that would be addition, that's 10 to the 40. On the bottom that would be 10 to the 4, and then I would subtract and get 10 to the 36. Again, if this number was not within this range, I may have to adjust the exponent here, whether it's moving it to the left or moving it to the right.